So these are going to be the nodes for the graphs of exponential functions. So first, let's start with the equation for the exponential parent function. And that's going to be f of x is equal to a times b raised to the x power. Now this b value right here is going to tell us whether our function is growth or decay. So first we have, if b is greater than 1, the function is an exponential growth. And it is increasing from left to right. So from left to right, your graph starts small and then it gets big pretty quick. So that's how it increases from left to right. Now on top of this, if the a value is 1, we have this thing called an asymptote. And we've seen those before. It's a boundary line that our graph cannot cross or touch. And exponential functions actually have a horizontal asymptote. So right by the flatting part where it kind of looks like it's going flat, we have our asymptote. And the equation of that is y is equal to 0. Now, if that b value is less than 1, then the function is exponential decay. And for left to right, it is decreasing. So from here, it starts big and then it gets small and it kind of looks like it flattens out. And again, it's approaching that asymptote, but it will never cross or touch it. All right, so that's what exponential growth and decay look like. And again, the b value dictates that. So when I look over here, again, we are reflecting back on that equation, y equals a times b to the x power. And this b value right there, again, if that's greater than 1, it's exponential growth. If it's less than 1, it is exponential decay. So for number 1, we see, how do I know which one is b? Well, b will always be raised to the x power. So here, 2 is going to be raised to the x power. So that's my b value there. That is greater than 1. So that is going to be growth. Here, our 1/2 is the b value because it's raised to the x power. That is less than 1. So we're going to call that decay. Again, 0.6 here is less than 1. That's raised to the x power, so that is also decay because it's less than 1. 3.5 raised to the x, so 3.5 is b. That is greater than 1, so that is growth. 0.3333 is like 1/3. That is less than 1. That is decay. Then last here, you'll notice we have 2 numbers here. And the way we tell which one is b, again, is because the b is raised to the x power. Therefore, the 4 is the a value. And this one is bigger than 1, so it's also going to be growth. All right, so let's go to classify as an exponential growth or decay graph, and then identify its characteristics. All right, so the assertion here, I have f of x equals 2 to the x power. Our b value right here is 2. That is bigger than 1, so that's exponential growth. Now, what we're going to do here is we're going to create a table. Notice the x value is already given. They give us -2, -1, 0, 1, and 2. What we're going to do is we're going to plug those into x right here. So we have 2 to the -2 power. And we can just go do that all the way through. 2 to the -1, 2 to the 0, 2 to the first, and 2 squared. All right. So pretty much what I would do at this point is I would just grab my calculator. I would type it in. So I like to use parentheses. So parentheses 2, close parentheses, raised to the -2 power. And then it gives me 1/4 when I type it in. The next one will give you 1/2. 2 to the 0 is 1. 2 to the first is 2. And 2 squared is 4. So again, I just typed that in the calculator to get those values. And now what we have created is a table. Here are my x values. And here are my y values. So the first one is -2, 1/4. So x is -2, 1/4. That's a rough estimate because that's for sure not 1/4, but I'm trying my best on that. -1, 1/2. 0, 1. 1, 2. Let's see, 2, 4. And now I can connect my dots to make my graph. And recall that we talked about the asymptote being y equals 0. And so we just make our left side of our graph close to the asymptote without crossing or touching. Okay, so in terms of the y-intercept, hopefully you recall that's when x is 0. So over here in our table, we don't need to actually go and figure that out because right here, here's our y-intercept. 0, 1. For our asymptote, it did not change. I told you earlier that it was y is equal to 0. It's our horizontal asymptote. Our domain, if you look, we have an arrowhead to the left, which goes to negative infinity. And we have an arrowhead to the right that goes to positive infinity. And remember, infinities always use parentheses. We do not include those. And then the range, we have an asymptote at the bottom, which is 0. And it goes to infinity. And again, we don't include infinity. So we use parentheses to show that they're not included. See if I can write this one a little bit nicer here. And that is number 1. All right, on to number 2. So for number 2, we're given f of x equals 3 to the x. So hopefully you see here that 3 is our b value. That is greater than 1, so that again is growth. All right, we're just going to create our table. So we're changing this x value to those -2, -1. And again, notice I always use parentheses here. 3 to the 0, 3 to the first, and 3 squared. Type each one in my calculator. Let it give me my answer. So 3 to the -2 is 1/9. 3 to the -1 is 1/3. 3 to the 0 is first. It's 1, sorry. 3 to the first is 3. 3 squared is 9. All right, over here I'm going to graph them to the best I can. So -2 and 1/9. -1 and 1/3. 0, 1. 1, 3. And 2, 9, 3, 4, 5, 6, 7, 8, 9. All right, connect our dots and make our graph. And to the left. And don't forget our asymptote at y is equal to 0. All right, our y-intercept again, we can look over here. It says 0, 1 again. For my asymptote, I think I said earlier it was y is still equal to 0 because we didn't move up or down. We'll get to some eventually where you can translate them up and down. Our domain has not changed. It's still a left side is going to negative infinity as the right goes to positive infinity. And our range, it's facing up. So the asymptote starts at 0. And the graph has an arrowhead going up towards infinity. All right, on to number 3. So number 3, here our b value is different now. It's 1/2. That is less than 1, so that is decay. Again, I'm going to 1/2 to the -2, 1/2 to the -1, 1/2 to the 0, 1/2 to the 1, and 1/2 squared. Type these in my calculator. 1/2 to the -2 is going to be 4, 2, 1, 1/2, and 1/4. All right, make our graph here. So -2, +4, -1, +2, 0, 1, 1 and then 1/2, 2 and then 1/4. Again, we want to get it close to our asymptote, going to the right and going up to the left. And don't forget to graph your asymptote. All right, and there is our graph. So our y-intercept, again, if you notice, it hasn't changed yet. Eventually it will. We just haven't done transformation, so that's why it's currently 0, 1. Our asymptote as well, it's still that horizontal line. That's the x-axis, so y is equal to 0. And even though it flipped to decay, notice it still goes left to negative infinity and right to positive infinity. And the range, that asymptote stays at 0, and we're still going to infinity. All right, let's check out number 4. All right, so for number 4, our b value is 2/3. Again, that is less than 1, so that is decay. We set up these equations. We plug in right here. We change that x to -2, -1, 0, 1, and 2. So 2/3 to the -2 is going to be 9/4. 2/3 to the -1 is 3/2. Anything raised to 0 power is 1. 2/3 to the first power is 2/3. And 2/3 squared is 4/9. And again, we're going to try our best to graph this. So -2, and that looks like 2.25. Negative 1 and 3/2, which is 1.5. 0, 1. We have 1 and 2/3. And then we have 2 and 4/9. So it's just slowly getting smaller. So it looks like that. And this one over here is going to the left like that. And there's my asymptote at y = 0. And we have our y-intercept still at 0, 1. Domain from left to right is -infinity to +infinity. And range is 0 to infinity again. All right, moving on to the next part of the notes. The natural base exponential function. So E stands for the letter Euler. So this gentleman named Leonard Euler created this letter. Mathematically, he found some use for it, but he is credited for coming up with this, called the Euler number. And for math, E is going to be an irrational number. Ooh, that's not nice looking. So again, E is an irrational number with an approximate value of 2.718281828, and it just keeps going on forever. The exponential functions with base E are called natural base exponential functions. Many real-world applications of exponential functions use the base E. Now, one thing I want to point out really quickly, if you look at the base E, that number is bigger than 1. So right now, if we just had like e to the x power, you could say that is exponential growth because the E is bigger than 1. Okay, and we'll get to application later. Let's go ahead and talk about how to graph these. So again, is this growth or decay? Well, the E value is bigger than 1, so we're going to call that growth. Later, we'll show you how to distinguish between growth and decay. And that's going to have to do with this right here. If that number is positive, then it's growth. If that number is negative, then it is decay. Okay, but that x was positive, so it's growth. So when you do this in the calculator, you're going to do e to the -2, e to the -1, e to the 0, e to the 1, and e squared. So I can't show you what it looks like, but I do have the calculator right here. So all you're going to do is you're going to turn the calculator on, clear it. You're going to press second, and then 2 buttons below the green second button is the letters LN. So you press second LN, and the E pops up. Our first one is -2. I type that in. And I'm just going to round this to like 2 decimal places. So it says 0.135. So that's going to be 0.14. All right, I'm going to do e to the -1 now. That's going to be 0.367, so 0.37. Anything raised to the 0 power is 1. E to the first is the original number, so 2.71828, so 2.72. And then I'm going to type in e squared, and that gives me 7.39. All right, we know we have an asymptote again at y = 0. That does not change. So let's see. So -2 and 0.14, somewhere right there. -1 and 0.37, just a little bit higher up. 0, 1. 1, 2.72, so that's getting close to 3. And then this next one is close to, it's almost 7.5. So 3, 4, 5, 6, 7, and somewhere in the middle there. And you notice if I added it one more number, it would go off the graph pretty quickly. All right, for our y-intercept, again, it has not changed. It's still 0, 1. Our asymptote is y = 0. Domain left to right, -infinity to +infinity. And our range is going to be from 0 to infinity because we have an asymptote on the bottom that is not included. All right, I'm just going to make sure, yep, that's going to complete our notes for today.